Hello everyone. In a previous class, we discussed about what is FET and what is MOSFET, metal oxide semiconductor field effect transistor, its definitions, types and working principle. In this lecture, we will study about what is the transistor used as an amplifier circuit. Circuit diagram of the transistor as an amplifier, working of the transistor as an amplifier. After this, we will move on common emitter amplifier circuit diagram. Next one is common emitter voltage gain. What is it? हम पढ़ेंगे कि voltage gain क्या है, कैसे निकाल सकते हैं हम common emitter configuration of the transistor. एक्चुअली हमने जब ट्रांजिस्टर स्टडी किया था तो उसमें हमने देखा था कि ट्रांजिस्टर के 3 बेसिक कॉन्फ़िगरेशन होते हैं, कॉमन बेस, कॉमन कलेक्टर एंड कॉमन एमीटर. तो हम देखेंगे कॉमन एमीटर कॉन्फ़िगरेशन में कैसे हम वोल्टेज गेन को कैलकुलेट कर सकते हैं. After this, we will move on the application of transistor as an amplifier in different areas. And finally, the reference of this presentation. So in this presentation, we will learn all these topics one by one. So let's start with the topic transistor as an amplifier. So what is transistor? Transistor is a 3-terminal semiconductor device, and the terminals are emitter in short E, base in short B, and collector in short C. So we can say that it is a 3-terminal device, emitter, base and collector. The transistor can work in 3 different regions like active region, cutoff region and saturation region. Transistors are turned off while working in the cutoff region and turned on while working in the saturation region. Normally जब ट्रांजिस्टर हमारा कट ऑफ रीजन में वर्क करता है तो हम उसको बोलते हैं कि ट्रांजिस्टर हमारा ऑफ कंडीशन में है, और जब ट्रांजिस्टर सैचुरेशन रीजन में काम करता है तो हम बोलते हैं कि ट्रांजिस्टर जो है वो हमारा टर्न ऑन कंडीशन में है. The transistor work as an amplifier while they work in active region. The main function of the transistor as an amplifier is to enhance the input signal without changing much. In this lecture, we will discuss how a transistor work as an amplifier. तो एम्पलीफायर होता क्या है, सबसे पहले हम ये समझते हैं. एम्पलीफायर एक ऐसी डिवाइस है या ऐसा सर्किट होता है जो कि हमारे इनपुट सिग्नल को एम्पलीफाई करता है, मीन्स उसके एम्पलीट्यूड को बढ़ा देता है, और सिग्नल को ज़्यादा चेंज नहीं करता है, केवल एम्पलीट्यूड को जो है वो बढ़ा देता है. जैसे कि आपके घर में वूफर होता है, वो साउंड एम्पलीफायर होता है जो कि एम्पलीफायर को बढ़ा देता है और उसके एम्पलीट्यूड को बढ़ा देता है. तो ट्रांजिस्टर का यूज करके हम एम्पलीफायर सर्किट डिजाइन कर सकते हैं. नेक्स्ट, so the question is, what is amplifier circuit? So amplifier circuit can be defined as a circuit which is used to amplify a signal, or we can say that which is used to amplify our input signal. The input of the amplifier is a voltage or current, where the output will be an amplifier इनपुट सिग्नल। सिंपल लैंग्वेज में हम बोल सकते हैं कि जो एम्पलीफायर सर्किट होता है वो तो इनपुट सिग्नल, चाहे वो हमारा वोल्टेज हो चाहे वो करंट हो, आउटपुट में उसको एम्पलीफाई करके हमें देता है, मतलब एम्पलीट्यूड को बढ़ा के देता है। An amplifier circuit which uses a transistor, otherwise transistor is known as a transistor amplifier. The application of transistor amplifier circuits mainly involve in audio, radio and optical fiber communication, etc. So these are the application where the transistor amplifier is used. Next is the transistor configuration. We know that about the configuration of the transistor. In a previous lecture we discussed about that. The transistor configuration are classified into three types such as common base, in short CB, common collector, in short CC, and common emitter, in short CE. But the common emitter configuration is frequently used in the application like an audio amplifier, because in common base configurations the gain is less than 1, or we can say that less than unity, and in common collector configuration the gain is almost equivalent to 1. The parameter of a good transistor mainly include different parameters, namely high gain, high slab, rate, high bandwidth, high linearity, high efficiency, high input impedance, and high stability, etc. So these are the parameters for the good transistor. This is the diagram for diagram A, bipolar junction transistor, in short BJT. So the region and the junction. 3 terminal, the name is emitter, base and collector, and 2 junction, base emitter junction and base collector junction. And second diagram, NP and BJT biased to operate in active region. So the next topic is circuit diagram for transistor as an amplifier circuit. A transistor can be used as an amplifier by enhancing the weak signal strength. With the help of following transistor amplifier circuits, one can get an idea about how the transistor circuit works as an amplifier circuit. In the below circuit, the input signal can be applied among the emitter base junction and the output across the RC load connected in the collector circuit. You can see the diagram. The diagram shows the transistor as the amplifier circuit. For accurate amplification, always remember that the input is connected in forward bias, whereas the output is connected in reverse biased. For this reason, in addition to the signal, we apply DC voltage VEE in the input circuit as shown in the above circuit. So in this circuit diagram, the BJT act like as a voltage amplifier circuit. इसमें हम इनपुट वोल्टेज दे रहे हैं, आउटपुट वोल्टेज जो है वो हमें एम्पलीफाइड फॉर्म में मिल रहा है। सर्किट डायग्राम में हम देख सकते हैं इनपुट वोल्टेज जो है उसका एम्पलीट्यूड हमारा कम है, बट जो आउटपुट में वी आउट साइड हमें जो यहाँ पे वेव फॉर्म दिख रहा है उसका एम्पलीट्यूड ज़्यादा है और एम्पलीफाइड फॉर्म में हमें मिल रहा है। सो दिस इज कॉल्ड द एम्पलीफायर सर्किट। Generally, the input circuit includes low resistance. As a result, a little change will occur in signal voltage at the input, which leads to a significant change within the emitter current. Because of the transistor act, emitter current change will cause the same change within the collector circuit. At present, the flow of collector current through an RC generates a hug voltage across it. Therefore, the applied weak signal at the input circuit will come out in the amplified form at the collector circuit in the output. This method, the transistor performs as an amplifier. The next topic is the working of the transistor as an amplifier. Let us consider a circuit of an amplifier designed with the basic common emitter configuration. In this configurations, the voltage is applied at the base and the emitter terminal. Because the junction present in between them is considered to be in forward bias mode, the considered output is taken across the resistor that act as a load which is connected in between the collector and the base. So this is the circuit diagram for transistor as an amplifier circuit. As the low resistance is present at the input side, in the circuit designed, the signals of low strength have been applied at the input and the output generated will be evident with the strength of its signal obtained. In this way, the transistor works as an amplifier. There are various types of amplifier exist. They are firstly the bipolar junction transistors that classified as a common base, common emitter and the common collector as its configuration. Secondly, the class or the classes of the amplifier classified based on the input applied and the output collected. They are class A, class B, class AB, class C and class D, etc. Lastly, the amplifier designed based on its main factor called efficiency. In order to achieve efficiency, it can be designed in the form of stages. They are single stage and multi-stage, etc. So these are the different type of amplifier. Next topic is a common emitter amplifier circuit diagram. नॉर्मली जो हमारा एम्पलीफायर सर्किट फ्रिक्वेंटली यूज होते हैं वो होता है कॉमन एमीटर कॉन्फ़िगरेशन वाला. तो हम इसी को स्टडी करते हैं डीपली कि व्हाट इज द कॉमन एमीटर एम्पलीफायर सर्किट. In most of the electronic circuits, we use commonly NPN transistor configuration, which is known as NPN transistor amplifier circuit. Let us consider a voltage divider biasing circuit, which is commonly known as single stage transistor amplifier circuit. This is the diagram for single stage transistor amplifier circuit. Basically, The biasing arrangement can be built up with two transistors like a potential divider network across the voltage supply. It provides the bias voltage to the transistor with their middle point. This type of device is mainly utilized in the bipolar transistor amplifier circuit design. So in this diagram, two resistors R1 and R2 connected with base terminal, RC connected series with the collector terminal, and RE connected series with the ammeter terminal. And one capacitor CE is connected parallel with ammeter terminal. So this is the circuit called as single stage transistor amplifier circuit. In common ammeter amplifier circuit diagram. In this kind of biased, the transistor will reduce the current amplification effect factor beta by holding the base bias on a constant steady voltage stage and permit precise stability. The VB is called base voltage, can be measured with the potential divider network. In the above circuit, the entire resistance will be equal to the amount of two resistors like R1 and R2. The produced voltage level at two resistor junction will hold the constant base voltage at the supply voltage. The following formula is simple voltage divider rule, and it is used to measure the reference voltage is VB is equal to VCC into R2 divided by R1 plus R2. Where VB is called the base voltage, VCC is called common collector voltage. R1 and R2 is the resistance. The similar supply voltage also decide the outmost collector current. As the transistor is activated, that is in saturation mode. The next is common ammeter voltage gain. Common ammeter voltage gain is equivalent to the modification within the input voltage ratio to the modification within the amplified output voltage. Consider Vn is called the input voltage and Vout is called the output voltage as delta Vb and delta Vl. Delta Vb is called the base voltage and delta Vl is called the load voltage. In this condition of resistance, the gain of the voltage will be equivalent to the signal resistance ratio with the collector towards the signal resistance within the ammeter is given as voltage gain is equal to output voltage divided by input voltage. In short, Vout divided by Vin is equal to del into VL divided by delta into VB. So the value of delta L in the form of resistance minus of RL divided by RE. By using the above equations, we can simply determine the common emitter circuit voltage gain. We know that bipolar transistors include minute internal resistance built into their emitter section, that is RE. Whenever the inside emitter resistance will be connected in series by the outside resistance, the customized voltage gain equation is given below. So the voltage gain is equal to minus of RL divided by RE plus RE. तो उसमें हम जब कस्टमाइज वोल्टेज गेन हमें निकालना है तो उस कंडीशन में हम इंटरनल रेजिस्टेंस जो है RE उसको भी हम ऐड कर देते हैं. The whole resistance in the emitter circuit at low frequency will be equivalent to the amount of the inner resistance and the external resistance, that is RE plus R into small e. For this circuit, the voltage gain at high frequency as well as low frequency include the following. The voltage gain at high frequency is minus of RL divided by RE. The voltage gain at low frequency is minus of RL divided by R into capital E, means RA plus RE. By using the above formula, the voltage gain can be calculated for the amplifier circuit. Thus, this is all about transistor as an amplifier. From the above information, finally, we can conclude that a transistor can perform like an amplifier only when it is biased properly. There are several parameters for a good transistor, which includes high gain, high bandwidth, high slow rates, high linearity, high input impedance, and high efficiency and high stability, etc. So the next topic is the application of transistor as an amplifier. Transistor working as an amplifier has various advantages and application in the field of electronic and communication. They are: number 1, it can be used in long distance communication because the intensity of the signals obtained at the output will be high. Number 2, in the radio signals amplification, these transistor amplifiers are utilized. Number 3, the amplifier play a prominent role in wireless communication. Next, the amplification of the signals using transistor as an amplifier can be utilized in the FM signal broadcasting. Number 5, in the optical fiber communications, also these type of amplifier are utilized. Mean in a fiber communication also we can use the transistor as in the amplifier circuit. Number 6, the basic application of the transistor as an amplifier is as an audio amplifier, and this is used in our day-by-day activities that we come across. So these are the various applications where the transistor act as an amplifier circuit. The next topic is the references of this presentation. So in this presentation, इसमें हमने सीखा कि ट्रांजिस्टर जो है वो एम्पलीफायर की तरह कैसे काम कर सकता है, उसका सर्किट डायग्राम, उसका वर्किंग एंड जो मोस्ट फ्रिक्वेंटली यूज्ड एम्पलीफायर ट्रांजिस्टर से हम बनाते हैं वो हम बनाते हैं किस वाले कंट्रोगेशन में, ये हमने देखा, जो कि कॉमन एमीटर कंट्रोगेशन जो कि बहुत ही फ्रिक्वेंटली यूज होता है। और एम्पलीफायर ट्रांजिस्टर एज एम्पलीफायर यूज होता है ज़्यादातर हमारा इलेक्ट्रॉनिक सर्किटरी में और कम्युनिकेशन फील्ड में। सो इसमें हमने ये सारा सब कुछ वन बाय वन स्टडी किया। फाइनली द रेफरेंस ऑफ दिस प्रेजेंटेशन इज so these are the references. electronichub.org, electricals or electronic for you, electrical for you. So anybody have any doubt regarding this topic, please ask me. And thank you for watching this video.